Alright, this is Math 2, Unit 8, Lesson 2, and we are looking at some homework help today of numbers 3, 7, 11, 13, 17, and 18. Looking today at areas of circles and sectors, and they begin with just some basics of finding the area of a circle. If you recall, the formula for that is right here, area equals pi r squared. And so in some cases they will give you a radius, in some cases they'll give you a diameter, which means they want you to cut that in half. This first problem wants you to take the diameter and cut that in half. For our purposes, I'll go ahead and do number 3. Number 3 begins with, first of all, a radius of 3.2. I want to make sure I have half of that, and half of a radius, if I divide that by 2, is actually half a diameter, sorry, would actually end up being 1.6. Okay, so now when I plug that into my equation, the area is going to be equal to pi times the radius, 1.6 squared, and that's where I am there, and it says leave my answers in terms of pi, so I do need to do 1.6 times 1.6, which gives me an answer of 2.56 pi, and because we are dealing with area, I have to look at my term here, and it says I'm looking at inches, so I get 2.56 pi inches squared for my solution for number 3. Now we're going to take that information there, sorry, I knocked over my phone. We're going to take that information then, or that concept, and now we're going to apply it to finding the areas of sections or a sector of a circle. Like we did earlier in lesson 1, we were looking before at the circumference and looking at a portion of that circle. Now we're looking at a portion of the area. So to do that, we're going to want to find what fraction of that circle we are actually talking about. Alright, so when we look at number 7, first of all, we have a 90-degree angle here. Because that's 90, it doesn't matter for now, but I know that arc, this is going to be 90 degrees as well. I want to find out what that percentage of that circle is going to be. So we start by finding the ratio of this circle. So I have a 90 here, which means I'm dealing with a 90 out of 360 degrees of the whole piece of pie, the whole circle. I can reduce that down if I choose. The zeros on the end can go away. 9 over 36 is the same as 1/4. Now from this point, I need to use the formula that you learned today about how to find the area of that section. The formula for that is going to be the measurement of the arc, which in this case we said it was 90, divided by 360, times the formula for the area of a circle. So we're saying I want to know what fraction of the area of the circle is shaded. So this is my fraction times pi r squared. So that's the formula we're going to be using to find out what's missing there. So knowing that, I have my ratio already for number 7, 1/4. I'm going to multiply that by pi, and then multiply that by the radius, which is 7 squared. So in this case, I have 7 squared, which is 49. Right? So I have 1/4 times pi times 49. And now I just have to use my calculators of math here. 49 divided by 4. 49 divided by 4 gives me 12.25. I still have a pi in the mix. I look at what my unit is. I'm dealing with centimeters, so now I know it's centimeters squared, and that's what I end up with. So it's important to start with that ratio, find out what the ratio is going to be, and then use your formula to multiply the ratio times the area formula for a circle, pi r squared, to solve towards that answer. Okay? Let's look at number 11, which is one that doesn't have a picture for you, but it still gives you the same idea. It says find the area of the sector QRS in circle R using the given information. Leave your answer in terms of pi. So they gave me a radius, and I have a measurement of a section here of 135. So I first want to find out my ratio, 135 over 360. I'm going to multiply that by my formula part, pi times r, which in this case is 4. They told me the radius is 4 squared. So when I move that on to the next phase, I have 135 over 360 times pi times 16. And again, what I'm going to do is I'm going to multiply 16 times 135 and divide that by 360. So if I was to do that on my calculator there, I could do 135 times 16 equals that, divided by 360, and I come up with 6 as my solution there. So I have 6 plus the pi, and I need to see what my units are. I'm dealing with inches, so 6 pi inches squared becomes my solution for number 11. Alright, let's look at the back side. On the back side, we're looking at number 13, 17, and 18. These questions are a little different. Took me a couple times to figure out what exactly we were doing today. So with these ones here, we're looking for the area of each shaded segment. On the previous page, we took the whole area of the whole segment, but now what we're doing is we're taking that little section here and we're drawing a line across it, and we're saying, oh, I just want to know this part. So really, if you look here, what we're doing is we're saying, instead of telling me the whole area of that whole section, we're going to take out this triangle. We're going to get rid of that and only count that portion of it. Alright, so to do that one, I'm going to start with number 13 because it's a little different, okay, in how you figure out the area of that triangle. So what we're going to do is we've got to think of it this way. I'm going to find the area of, right here, I'm going to find the area of the sector in this case, and I'm going to subtract from it the area of the triangle. That's what I'm going to do in this problem right here. So let me first of all find the area of the sector. I'll write that right here. Here's my sector portion. My sector, I have 120 degrees, so this is my 120. So the formula from before was find the ratio, 120 out of 360, times the formula for the area of a circle, pi r squared. My r is 2, and we square that. So I have 120 over 360 times pi r squared. So I can reduce, zeros go away, 12 and 36 is 1/3. So 1/3 pi, 2 squared is 4, and times 4. So what I end up with is 4/3 pi, or if I was to break that down further and divide it out, whatever, I end up with 1.33 for a long time times pi. I'm not too worried about my answer right now because it does say to round to the nearest tenth, so I know I'm going to be dealing with a lot of decimals. So it goes on for 333 for quite a while. So that's my sector part. Now we said a moment ago, we want to take the area of the sector and subtract from it the area of the triangle. So I need to determine this area here. What we're going to do, and for this part, I had to go ask some teachers, what are you showing the kids? Here's what we're doing. We know that this angle is 120. If I draw an altitude right here, and I cut that in half, that angle in half, to form a right angle, now instead of 120, I have two angles that are half of that, which means I have 60 right here. Okay, let me just draw this triangle a little bit larger for you. A little bit larger. So what are we talking about here? We took this large triangle and chopped it up into two parts. Okay, so now I have a 60-degree angle here, which makes this angle 30 degrees and a 90. If you remember back from one of your previous units, we know how to solve these for missing parts by looking at a triangle that's a 30, 60, 90. And I used to draw it this way on some previous lessons, remember. We drew it like this. We had our 60, our 30, and our 90. And what we said was this was A, or X. This was 2 times the base. And over here was the base times root 3. So knowing that information, we already can tell that this line right here is 2. Well, that's my hypotenuse is 2, which means my A value is half of that, right? 2 times A would be 1. It's going to be 1. So my base is 1. And so that's my A. My A is 1. So this part, my length of this part, is going to be that times root 3. So it's just root 3. So if you look at your triangle this way, now I can turn it sideways if you like, and I have a base and I have a height. So now I can find out the area of this triangle. But notice it's just one of the triangles. I actually have 2 of these. So when I do the area of the triangle, area of the triangle. I have triangles, so I'm going to do 2 times my formula, 1/2 times the base times the height for my triangle here, because I split it in half. In this case, I know 2 times 1/2 is still there, no problem. My base, we said, was 1, and my height is here at √3. Well, 2 times 1/2 is 1, those reduce, times 1 is still 1, times the √3 is just simply √3. So my area for this whole triangle is √3, all right? So I know the area of the big sector is 1.33 pi. I know the area of the triangle is √3. So now, to determine what the area of just this shaded figure is, I'm going to take the 1.33 pi and I'm going to subtract from it √3. Alright? So for me, if you use your calculator, I found out that √3 is the equivalent of about 1.732. That's kind of what I came up with there. 1.33 times pi, if you multiply that together, off the side again, sorry, 1.33 times pi is going to give you about 4.1762, just kind of stop somewhere. And when I do 4.17 minus 1.73, I end up with 2.44. So it's pretty close to the answer. If I round to the nearest tenth, if I go tens, hundreds, I look next door, I got to look and say that's less than 5, so I'm just going to go ahead and chop it off there. So the nearest tenth, I end up with 2.4 as my solution there, and at 2.4, I'm dealing with meters squared. I'll tell you, the answer key for this question does say it's 2.5 meters squared, but again, we're just trying to round it and get it pretty close to the approximation there, so I'm not too far off from the actual solution. So I'm okay with that. I'm going to leave it there. The key was to say I'm going to take the sector, find that area, here it is, and then find the area of the triangle, here it is, and it's actually 2 triangles, so be careful there. Make sure you multiply by 2, and then subtract those to find the difference to see what's left. Alright, let's take a look at another one, because that's using some subtraction there. Let's take a look at number 17. The same idea here is in number 17 as we did just above. I'm going to find the area of this region, and the first time I did it, I'll tell you what, I went ahead and I did the area of the whole thing, and then I subtract something. But let's say I can do it a different way. I can actually take the area of this portion of the circle and add it to the area of the triangle. I'm going to add these two parts together. That might be a little easier for you. Okay? So in this case, I have a 90-degree angle here. Well, what's left over here of this big circle? Well, I can do 360 minus 90, and that tells me that what I have left is 270 degrees. So this section here, if I do my section part first, right, so my sector is actually 270 divided by 360 times pi times the radius squared, which was 100, is 12, I'll skip a skip, don't skip, 12 squared. Good so far? So now if I multiply this out, 12 squared is 144 times 270 divided by 360. Alright, so if I just get the calculator out real quick for you, I can do 270 divided by 360 equals 0.75 times 12 squared is 144, and I end up with 108 pi. Okay, so this section right here, the triangle, is 108 pi. That's how big that is. Now I need to add to it the area of the triangle. Alright, so here's my triangle section here. My triangle is, formula for the area of a triangle is 1/2 base times the height. This is a right angle triangle, so I don't have to do the other part we did before with the a and √3. I just have 1/2 times my base is 12 and my height is 12. So 12 divided by 2 is 6. 6 times 12 happens to be 72. So this is 72. And now I just want to add those two parts together. And the way you write that is you just leave it, it says in your directions say leave it in terms of pi and in simplest radical form. So we would say for number 17 that it's 108 pi plus 72. And that's all of that is going to be centimeters right here squared. So that's my solution for number 17. Let me show you number 18 because it does bring us back to one of those questions where we have to use a little bit of an altitude to figure out what's happening. All right. First of all, my sector. No problem with the sector. I can see this is going to be whatever is left after 120 is taken out of 360. So 360 minus 120, I get 0, 4, 240. So for my sector, I have 240 over 360 times pi times the radius squared. Okay, so once again, 240, oops, sorry about that, here's my calculator here. 240 divided by 360, oh, wrong number, 240, 240 divided by 360 gives me that lovely 0.66666 forever and ever and ever and ever and ever and ever and ever times pi times, go 30 times 30 is 900. Put a bunch there. End up about 59999 forever and ever and ever. If I do it a different way, I probably should actually. Let's do it this way. Let's go ahead and erase that real quick because you can't get a whole number there. I can do 900 times 240 and then divide that, divide that by 360 and I end up with 600. Okay, so let me just do that all just one step there. So my sector ends up being 600 pi. 600 pi for this portion right there. Now the next part I want to do is I'm going to want to figure out how to find out my my triangle. Once again, because I have 120 degrees here, I can drop an altitude there. This becomes my 2a, right? So the base becomes half of that, which is 15, and then my height becomes 15 root 3. That's just my triangle for a 30, 60, 90 triangle. So essentially it looks like this on paper. I already knew this was 30. That became half of it, which is 15, and then my height became 15 root 3. So to find the area of my triangle here, remember there are two triangles, so it'll be 2 times 1/2 times the base, which is 15, times the height, which is 15 root 3. My 2 times 1/2 is going to go away, so I'm left with 15 times 15, which is 225 root 3. Remember it said to keep it in terms of pi in simplest radical form. So to do this one here, I'm going to be adding these two together. I'm adding this plus the triangle to that. So my solution will be 600 pi plus 225 root 3. All of that is multiplied by inches squared for my area of that shaded region. All right, that's it. Hope that helps some.